Now, at this point, or till this point, function was concave down. After this point, it starts to be concave up. So where the concavity is changing, that point is called point of inflection. Actual definition is here. Inflection point or point of inflection is where the concavity is changing. I mean, on the right hand side, concavity up, on the left hand side, concavity down, or on the right hand side, concavity down, on the other side, concavity up. So what is this number here? That number is called point of inflection. So to solve the question, you are ready, right? You are listening?
Yes, sir.
So important. It's so essential. Please don't do anything. Just look at the board. So always we start with f prime of x is equal to 0. So 0 equals 4 times x cubed by 4 times x cubed minus 6 times 2, 12, x plus 0. That's it, finish. Since 4 is it clear the first derivative? 4x minus 12x? I think this is clear. So 0 is equal to 4x, common parenthesis, I can say, x squared minus 3. Let me check, 4x cubed and 4x, that's correct. So 0 is 4x, so x is 0. And x squared minus 3 is equal to 0. X squared is equal to 3. So x is equal to plus minus root 3. Till here, do you have any question? Yes, no? No. Okay, so let's make a table. By the way, are they in the domain? Any of them makes the function undefined? No, this is polynomial function. So negative root 3, it's clear that the smallest number. 0 is between them. And positive root 3, I can say that it is here. And f prime of x is equal to here. Now, let me write f of x, it's here. Now, my dear students, this makes it 0. This make it 0. This make it 0. I mean, the number negative root 3 makes my function 0. And my derivative 0. Number 0 makes the derivative 0. Number root 3 makes the derivative 0. What about the leading term? When I have 4x cubed minus 12x, 4x cubed is leading term. What is leading term? Where do you have the maximum x power? So leading coefficient is 4, which is greater than 0. So plus, minus, plus, minus. Till here, do you have any question? Yes, no? So let me copy, by the way, f of x is a little bit up. So then what will be f of x? Let me show you f of x. Let's have a look, guys. Changing the color. So it is decreasing. It is decreasing, increasing, and increasing. So by looking this figure, it's clear that here I have the local mean, here I have the local mean, here I have the local max. So mean, max, and mean. So the answer of the first question, part A, f of x has local minimum at x equals negative root 3 and x equals positive root 3. Finished. F of x has local maximum at x equals 0. What about local minimum value, local maximum value? Just put it in the original function. F of 0, f of negative root 3, f of positive 3. That's it. Now, part B. Now, pay your all attention to the board, guys. Pay your all attention. Part B asking the concavity. Concavity means second derivative is in charge, where the second derivative is equal to 0 or undefined. Okay, so first derivative was this. So Abdullah, what will be second derivative? Second derivative will be derivative of the first derivative, which is derivative of 4x minus 12, which will be derivative, which will be 12x squared minus 0. So this is equal to 0. So 12x squared is equal to 0. So x squared is equal to 0. So x equals 0.
0.
Do we have any questions for this? X equals 0. Now, do we have f double prime of x is undefined? Do we have anywhere this function is undefined? 4 times x minus 12? No. So the critical point is only 0. So be careful now. What am I going to do? X f double prime of x and f of x. The root is 0, but it is double. What does it mean, double, guys? It means when the leading coefficient for x cubed, leading coefficient, which means 4 is greater than 0, which means positive, here positive, these have to be also positive. We are not changing if you have double root. Now, concavity. If the second derivative is positive, concavity is up. If the second derivative is positive, concavity is up. So what will be the answer of the question? F of x is concave up where? From negative infinitive up to 0, union from 0 to positive infinitive. That is it. Finished. Now, answer of C. Find the inflection point. Inflection point is a point that where the concavity is changing from up to down or from down to up. So do you have any point change the concavity? Do you see any point here? Concavity is changing. I can't see. So there is no inflection point. Is this clear, guys? Why there is no inflection point? Is this clear? Since concavity is up and up, inflection point is a point where the concavity is changing. For example, here, let me show you one more time. Clean all. So concave up, concave down, sorry, look, concave down till here, and then it starts to concave up. So the point where x is equal, I don't know what is that here, negative 1, let's say, or whatever, not important. So this is now singular, I mean the inflection point. So this point is inflection point. Why? On the left, concave down, on the right, concave up. So in my question, there is no inflection point. So the solution of our example, when we check it, so what we say, let us read together. Let us read. This is another example. 1 minute. I can't see it. So the roots are, I am checking. 0, negative root 3, positive root 3. So increasing where the function increase, negative root 3 to 0 and root 3 to 0. So let's check our whiteboard where it is increasing. Why I can't see my whiteboard? 1 minute. Let me share again. Here, where the function is increasing, guys, I didn't write, let us write. From negative infinitive up to negative root 3, function is decreasing. From 0 to positive root 3, function is decreasing. So I can say that also from negative infinitive up to negative root 3 and or union from 0 to positive root 3, it is increasing or decreasing down, right? So decreasing, decreasing. And where it is increasing, negative root 3 up to 0, union positive root 3 up to infinitive, it is increasing. Let's check it again. So yeah, here increasing, here increasing, here decreasing, as we said. Very good. Now, the second part of the question, when we check the double roots, what is doing here? I couldn't see. For the concavity, we have 1 minute. Second derivative, isn't it 12x squared, guys? Oh, 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 oh. Okay, everybody, have a look, have a look, have a look, have a look. Are you here? Guys, are you here?
Yes, yes.
When I copy paste the first derivative here, I did a mistake. This is not 12, this is 12x. Look, 12x. So everything will change here for the concavity. Since 12x, it's not 12. Derivative of 12x will be 12 here. It means that 12x squared is equal to 12. So x squared is equal to 1. X squared is equal to 1. So x is equal to plus minus 1. So when I check it here, now 1 of the root and other root. So what should I say then? What should I say then? This table will totally change. Sorry for this. But it's good to see, to catch the problem. So when the problem again, when I copy down the derivative, I copy down wrong. So again, let me solve. So this is the first derivative. Oops. Okay, I'm writing again. So I'm starting the part B again. Okay, part B again. So part B and C will automatically change. So first derivative is equal to 4x cubed minus 12x. So f double prime of x is 12x squared minus 12. So this is equal 0 means x squared 12x squared is equal to 12. So x squared is equal to 1. So x is equal plus minus 1. Now the table x, f double prime of x, and the function f of x. The roots are negative 1 and positive 1. Negative 1 and positive 1. Now, 12x squared, 12 is greater than 0, so plus minus plus. Now, since this is positive concave up, since this is positive concave up, here concave down. So what should I write? F of x is concave up, where from negative infinitive up to negative 1, union from 1 to infinitive. Do we agree for this? Please have a look at the table and this sentence. And concave down, where on the interval negative 1 comma 1. Please check it quickly. So concavity means second derivative table we are using. If no question, part C, inflection point is where the concavity is changing. So you see up to down, where it changes at point 1. Down to up, where it changes at point negative 1. So inflection points are x equals -1, and x equals +1. So when we look at our case, concavity up from -infinity to -1 and +1 and infinity, which is here, we said, and it's concave down where it is here from -1 to +1. It's okay. And now point of inflection, where is it? At -1 and at +1. So the coordinate of point of inflection is when x is -1, y is -4. When x is +1, y is -4. How can I find this -4? How can I find? How can I find? Of course, in the original function, what is f of -1? In the original function, what is function f of 1? So this is the function. So function is decreasing, 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 and then start to increase, start to decrease, start to increase. Point of inflection here till this point, which is -1, it is concave up. After that, at this point, it is concave down, and then at this point, concave up. So from this to this, concave up, this to this, concave up, from this to this, concave down. Now, there's a new example, but I want you to check it, these calculations or this page one more time from the beginning. Please have a look. If there's any question somewhere, tell me. If not, I will continue next example. I am waiting you. Yes, any question?
No, no, sir.
Okay. Guys, do not forget, AP Calculus is for engineering students in university. It is first term mathematics lesson, Calculus 1. It's the first term, Calculus 2 is the second term. So we will learn Calculus 1 and Calculus 2 in AP Calculus. I mean, all the year of the first year of university, we are studying. So this is extremely difficult subject. You have to be really good in mathematics. Otherwise, it's normal not to understand. Okay? These are not simple topics, Simon. These are difficult topics. So if I am trying to major in business administration, is AP calculus useful? Humam, AP calculus could be useful, but if I were you, I don't prefer to take. Statistic is better for the business. Instead of AP calculus, statistic is better. I mean, you don't need to take the AP calculus to go to business. For engineering, for sure, yes. But tell me, for business, AP calculus, you don't need. Even you will not see AP calculus and calculus lesson in university. You will see basic mathematics and statistics. I know it's difficult. For that reason, I am saying. You can talk with your coordinator. I can't tell you that you drop it, but I can say this, it's normal. But at the end of the year, you may fail. You means I'm not talking to you directly. I will try my best. You know, when you do your quiz, when you do your homework, when you do your project, so especially for the project and the quizzes and the presentation, I mean, you are being here, you are asking the question. These are the positive things, so you will pass. But not coming to lesson, not doing the quiz, not doing the homework, not doing, directly fail. So it is totally up to you guys to continue or not. What about software engineering? Abdullah, software engineering, 100% you will take this lesson in the first year of university. So I used to teach in university in Izmir. 3 years I have been part-time lecturer. So I have given this lesson, and you can check my YouTube channel, but it was English question, but explanation was Turkish. So the question and the solutions was there. So for all engineering students, they have to take this lesson, they have to pass. And not only passing, I am making the PhD in image processing, pattern recognition, I'm computer engineering. So without knowing calculus, you can't do anything. These are the essential, simple things you have to know when you write codes, when you create algorithm. So you have to know all these things, especially for the artificial intelligence, machine learning, linear algebra, calculus. These are the main subjects you have to know. Otherwise, you cannot be successful students. Just you can copy paste from the codes and you can pass like your lesson. But this is not being a real software engineer or real programmer. So for all kind of engineering students, this lesson is excellent lesson. So I am helping you for your university mathematics right now. You may think like that. Okay? So when you will be in university, none of the university professors will take care of you like this. They will just explain and they will leave the class. I mean, they will not ask you, did you understand? Did you understand? If yes, okay, let me explain again. No, forget about this. Normally, they are not doing this. Just explain and they go. Since I am teacher, my base is being a teacher, and then I used to work in university as a lecturer. So like a teacher, I always help the students. I do empathy. Anyway, so this is another topic. Let's go on now. Our question, determine the concavity for this and locate any inflection point. It's so simple. Only concavity is the question. So first derivative, 4x cubed. Second derivative, 12x squared. So second derivative is 0, 12x squared is 0, x squared is 0, x is 0, but double root. Don't forget this. And table x, f double prime of x, f of x. We have only one root, which is double, which is 0. And then 12 is positive, so plus minus. So concave plus plus. Since this is double, we keep the sign. And then concave up. So the answer of the question, determine the concavity from negative infinity up to 0. Union 0 to infinity, concave up, and no inflection point. Why no inflection point? Since concavity is up and up. Inflection means up to down or down to up. That's it. We solved the question. And by the way, for this table, if you have difficulty, guy, I have something very simple for you. So 0 on the right-hand side, think one number, for example, number 1, number 2, number 3. Put it in the function, put it here. 12 times 1 square, which is 12. So it is positive. You see, it must be positive. On the left side, for example, negative 1, negative 2, negative 3. I put it 12 times negative 1 square is positive 12. So positive, positive. Understand? What I solved here, for example, you may have a look, guys. So I'm saying that greater than 1, 2, 3, 4, 5, 6, 7, whatever. So I'm saying that second derivative positive. Put it here. Take it number 2. 2 square is 4. 4 times 12 minus 12, it's positive. But take it any number between negative 1 and 1. For example, 0. Put here 0. 12 times 0 square is 0. 0 minus 12, negative. And here, negative 2, when you take, it will be positive. I mean, if you have difficulty to understand, you can double check. Root 3, it's here. So take it 4. When you have 4, f prime must be positive. Put it here, 4 cubed times 4 minus 12 times 4. It will be positive. You will see. Now, let's see the solution in our book. So what it says, there is no inflection point. There is no inflection point. What about concavity? You see that concavity is up. So what we say for the concavity, where does it say? So function is concave up. But here it says that f double prime of x is greater than 0 for all x is different than 0. So when x is 0, it's not, we don't have concavity. So we can say that better negative infinitive to 0, union 0 to infinitive, as I explained to you. Now, concavity at critical point. So f double prime is c, f double prime any number 0. That means I have local max or local mean, here local max. F double prime at the given point less than 0 means there the function is concave down. So let us read, blah, 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 concave down, it press local maximum. Okay, and here horizontal line, so 0, and here concave up. Okay, as we explained. Now, this is called second derivative test. I mean, what is that here, guys? This one. It is called second derivative test. I mean, if f double prime of any number less than 0, f of c must be local maximum. If double prime of c greater than 0, f of c must be local minimum. Why? Simple. If you have something up, you have minimum. If you have something down, you have max. That's it. If second derivative is less than 0, it means you have concave down. If concave down, you have maximum. If second derivative is greater than 0, you have concave up. And so you have there local minimum. It's so simple. So use the second derivative test to find the local extrema. It's so simple. I say that f prime of x is equal to, so f double prime of x is equal to, so equals to 0. So now when I draw the table x and f double prime of x, double prime of x, and f of x. So what can I say? This is negative 4 over 3. This is positive 4 over 3. So plus or minus, since 12x squared positive, negative positive, concave down, concave up, concave, if it's positive, concave up, right? Concave up. And if it is negative, concave down. And then what can I say? Let's go now. So what it says, the critical point says x is 0, x is 2, x is negative 2. When I put in the second function, this, so max, mean, mean. Okay,